Marie Curie was a Polish scientist living and working in Paris. She and Henri Becquerel laid the foundations for understanding radioactivity, which was the word Marie Curie came up with. At the time, everyone thought radiation was made up of waves, even though we now know it's mostly particles. One big question was, how did uranium manage to radiate all the time? When you burn a match, there's a chemical reaction between the wood and the air, and the match eventually burns out. This didn't seem to happen with uranium. It didn't seem to be running out of anything. No matter what chemical reactions the uranium underwent, the amount of radiation never changed. Its radioactivity only seemed to depend on how much there was, not what it was combined with. This suggested that it was something about the atoms of uranium themselves that was producing the radiation. Marie Curie's research was happening before Rutherford had deduced that atoms had a nucleus, so she had no good model for what might be the source of the radiation. Marie Curie, her husband Pierre Curie, and Henri Becquerel were awarded the Nobel Prize for Physics in 1903 for their work on radioactivity. Marie and Pierre continued to search for other radioactive elements. They found that pure uranium metal was actually less radioactive than the ore in which it was found, called pitchblende. In this apparatus, the radioactivity is shown by how quickly the electrically charged gold leaf falls down. It falls quicker with the pitchblende, so it's more radioactive. Marie and Pierre reasoned that this must be because there were other radioactive elements in the pitchblende that hadn't been discovered, because they were only there in minute quantities. And to make such a big difference to the overall radioactivity, these trace elements must be highly radioactive. They started with several tons of pitchblende, and after 3 years developing advanced refinement techniques, they managed to isolate less than a gram each of 2 new highly radioactive elements that were naturally present in the pitchblende. One she called polonium, after her native Poland, and the other radium, because of the amount of radiation it gave off. Pierre was tragically killed in a road accident in 1906, so it was Marie alone who was awarded the Nobel Prize for Chemistry in 1911. She's the only woman to have won 2 Nobel Prizes and the only person to have been awarded a prize for different disciplines, physics and chemistry. Radium became important for the development of physics because it could produce a concentrated beam of radiation that could be used in experiments. Marie spent the rest of her life promoting medical treatments based on radiation.